In this question, in question 3 from the paper 1, we're looking at the concept of units, attributing units to numbers. Now, this is very much a skill that you would use in topic 1 stoichiometry, but it goes across all calculations that you would perform for any IB subject that involves numbers. So if you're doing physics or IB chemistry and there are units involved for the measurement, you need to be able to manipulate units. So these questions are great for separating those people out who can do that and those people who have no idea. Now, these questions are actually easier than they look. So once you learn how to do a few of them, you should be quicker at doing questions like this. The key for this question, as I've identified down here, is to be able to identify the final unit that you're trying to work towards. Now, in the question, they tell you that you're looking to figure out the volume in decimeters cubed of hydrogen gas that could be produced in this reaction. And they tell you that you're starting with 0.30 grams of magnesium. So the focus here is on the magnesium reactant. Now, what we can also do is we know that the molar mass of magnesium is approximately 24, but you can see in the question here that in the various formulae, they refer to 24.31. In all 4 formulae, you can see here, 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 and the one above at the first option A. So that's where the 24.31 is coming from. The 0.30 grams is coming from the mass of magnesium that you're given to begin with. And then the 22.7, this here is what we call the molar volume of an ideal gas. So this is the volume which is occupied of 1 mole of any gas. And that has units of decimeters cubed per mole. So what we need to do is we need to attribute our units to each number in each of these formulae, and then just figure out which one gives us the target unit of decimeters cubed. It's straightforward as that. You don't need to spend time trying to think what formula are they using and what's the concept behind this. You just simply have to manipulate the units. So let's go and do that. So let's get a different colored pen here. We're going to use blue. And what I'm going to do is I'm going to write the units beside the numbers. So the 0.30 will give us units of grams for the mass of magnesium. The 2 has no units that you can spot at the moment. I'll come back to that in a second. The 22.7, as we said, excuse me, I'm just writing units, was supposed to be decimeters cubed per mole. The 24.31 then would have units of grams per mole. Now this 2 is actually trying to trick you into looking at the 2 which comes from the 2 moles of hydrochloric acid. But of course, that's not the reactant that we're focused on here. We were told we were dealing with magnesium. So already we can say the first answer is not the correct answer. That also eliminates very quickly, if we scroll down here, that also eliminates the 4th answer, which has disappeared for a second there. But in the 4th answer, they also use the number 2 there as well. And again, that's relating to the hydrochloric acid, so we can eliminate that equation very quickly too. So now we're focused on just 2 possible equations. So in our 2 possible equations here, we have option B or answer B or option C. So already we're only a few minutes into this question, and we'll finish it off pretty fast now. So in option B here, we have 0.30 grams multiplied by molar volume of 22.7 decimeters cubed per mole. Then on the bottom, we have, let me just tidy that number up for you. So 22.7 decimeters cubed per mole, should be a bit more legible, over 24.31 grams per mole. Now, as you can hopefully see here, the reciprocal moles or moles to the -1 will cancel with each other. The grams will cancel with each other, and magically this gives us units of decimeters cubed. So it has to be answer B. Just to show you why it isn't answer C, when you look at answer C, again with this approach just attributing units to the numbers, the 0.30 would give you units of grams again, but this time we have grams per mole on the top, and we have our decimeters cubed per mole on the bottom. Now our moles will cancel, but the final units in this case would be grams squared times decimeters cubed to the -3. When you bring this back up to the top, it becomes dm to the -3. Now this is not the target unit of volume for the hydrogen gas. So that's why the answer for this question is B.